A team of astronomers reported in the journal Science this month that a rocky planet called LHS 1140b has a real, persistent atmosphere. And this is the first confirmed case of any rocky world sitting inside its star's habitable zone. Holding onto air, the planet orbits a small red dwarf star about 48 light-years away in the constellation Satis, and researchers detected helium actively escaping from its upper atmosphere using a ground-based instrument called the Warm Infrared Ekel spectrograph, mounted on the Magellan telescope in Chile. That escaping helium is not bad news. It is proof the planet has an atmosphere it has been holding onto for more than 3 billion years. For a field that has spent the last 2 years watching NASA's James Webb Space Telescope find nothing but bare rock around nearby red dwarfs, this result landed as a genuine surprise. Let us sort the signal from the noise. Start with the term doing a lot of work in every headline about this planet. A habitable zone is the range of distance from a star where a planet's surface temperature could allow liquid water. Not too hot, so the water boils away. Not too cold, so it freezes solid. It says nothing about whether a planet is actually habitable. Only that the temperature math allows for the possibility if the right ingredients, like an atmosphere and water, are also present. LHS 1140b sits comfortably inside that zone around its star, which is exactly why astronomers have been watching it closely since its discovery back in 2017. The planet is larger and denser than Earth, with a radius estimated at about 1.7 times Earth's and a mass several times greater, putting it in a size category between Earth and Neptune that does not have a clean analog in our own solar system. Whether that extra size means a rocky surface with a thin atmosphere, or something closer to a small, water-rich world, has been the central open question driving years of follow-up observation. Walk through how you actually detect gas escaping a planet 48 light-years away. As LHS 1140b passes in front of its star from our point of view, a small fraction of the star's light filters through the planet's upper atmosphere before reaching telescopes on Earth. Certain gases absorb very specific wavelengths of that light, leaving a signature astronomers can measure. The research team looked specifically for helium, because helium escaping a planet's atmosphere is easier to detect than heavier gases and serves as a reliable marker that an atmosphere exists and is being actively lost to space. The way a slow leak still proves a tire is inflated. They found exactly that signature. And modeling the rate of escape against the planet's age suggests the atmosphere has persisted for over 3 billion years rather than being a fleeting, recent event. That duration matters. A temporary or one-time atmospheric event would be a far weaker case for calling this an atmosphere the planet meaningfully holds onto. This finding matters mostly because of what has not been found everywhere else. Over the past 2 years, the James Webb Space Telescope has checked the atmospheres of multiple rocky planets orbiting red dwarf stars, including several in the well-known TRAPPIST-1 system. And in case after case, found essentially nothing. Bare rock with no detectable air. Red dwarf stars are smaller and cooler than our Sun, but they are also prone to intense flares and strong stellar winds, especially early in their lives. And the leading explanation for all those bare rocky planets was that this radiation simply strips away any atmosphere a planet starts with. That pattern had astronomers genuinely worried that habitable zone rocky planets around the most common type of star in the galaxy might almost never keep an atmosphere long enough to matter. LHS 1140b breaking that pattern, holding an atmosphere for billions of years around its own red dwarf. is the first concrete data point suggesting the bare rock pattern is not a universal rule. Here is what this discovery does not tell you. Detecting escaping helium confirms an atmosphere exists. It does not reveal what that atmosphere is mostly made of. And researchers still do not know whether LHS 1140b has a nitrogen-rich atmosphere similar in spirit to Earth's, a thick hydrogen and helium envelope left over from formation, or something else entirely. Those are very different planets with very different implications for habitability. The planet's size and density also keep it in a genuinely ambiguous category. Some models describe it as a rocky super-Earth, others as a small, water-dominated world sometimes nicknamed a Hycean planet. And this single measurement does not settle which model is correct. Having an atmosphere also is not the same as having a habitable surface, or any surface at all in the way Earth has one. And it is absolutely not evidence of life. Ground-based spectroscopy like this is also harder to fully verify than space-based data. And follow-up observations, including additional James Webb time, will be needed before astronomers treat this result as fully settled rather than a strong first signal. Quick recap. Astronomers using a ground-based spectrograph in Chile detected helium escaping the atmosphere of LHS 1140b, a rocky planet 48 light-years away sitting inside its star's habitable zone. Evidence the planet has held an atmosphere for more than 3 billion years. Published this month in Science. So, signal or noise? Signal. This is peer-reviewed, uses an established detection method, and directly contradicts a worrying pattern where every other rocky, habitable zone world checked by James Webb has come up bare. Some noise risk creeps in only if you read this as confirming a livable planet. It confirms an atmosphere. Full stop. Not surface conditions, not composition, and not habitability in any meaningful sense yet. The honest takeaway. A real and important data point that reopens a question many astronomers had started to consider. Closed. Subscribe for the space discoveries explained without the headline exaggeration. Signal from the noise. Every week.